All right, let's begin. Hello, everyone. Thank you for tuning in. I see a lot of people in the chat. Welcome. Welcome, Mehdi. Welcome, FTA. Let's see. I'm waiting for the short tutorial, like the cleanest way to write server actions. Yeah, that's going to be really fun to make, even for me. I think it's going to be fun to compress and like digest the whole live stream and compress it into a more, shorter, cleaner tutorial. That's going to be fun. Hey, Marco. Um, I liked your first episode of Clean Architecture. Thanks. That was actually really cool because I put zero practice, literally zero practice into coding the whole thing. It's just like we're gonna figure it out. We'll figure it out on our own. Yeah. Can you try to implement some effect patterns, such as for error handling using the effect? I was looking at effect, and for those of you who are not aware, effect.website. This is what Mehdi is referring to. It's like a meta framework for TypeScript, just like Next.js is a meta framework for React. I like it. There's some really cool stuff in effect. I don't like that if you start to use it, you have to use effect everywhere, right? You can't just use it for this slice or for this part of the app. But I do like it. I think it has like a steep learning curve, but I guess once you figure it out, once it clicks for you, you will be able to move faster and implement things. Yeah. Let's begin. I did some research, of course, and for today's stream, we need to demo the output schema because I received a comment on one of the videos. I think it was the first episode to demo the output schema. I did. If you followed the last stream, I ended on a bunch of errors because we moved some folders around, and the how to move, how to rename, how to fix imports didn't actually work. So I took the time last night to go through all of that, fix everything up. It was just changing imports, nothing else. And then I also fixed the... Hey, Andres, how's it going? Welcome. And I also fixed the returning values of the actions so that we can, show some UI feedback, etc. So I need to demo that. Then we need to talk about setting up the services in pages, not just in actions. And we have a couple of things in there. And at the end, we'll talk about error handling and how to, how to throw, how to catch, how to handle errors, how to show feedback on the UI, etc. Arup, hello, how's it going? All right, so let's dive in. Let's dive in. First on the agenda was to demo the output schema. And let me know if this is, hold on, let me say this. Let's go to localhost 3000. I think I'm running the app right now. Yes, we are running the app. And I'm logged in, all cool, yeah. Check this out. You can actually drag these around. Like how cool is that? Just a little fun thing that I made for the landing page. But yeah, here we are. Demo the output. So inside of the sign in, sign up, all of the authentication screens, we were invoking the server actions, but not through the form, like form action, but just await invoke the server action. And because I'm using, yeah, I do need to zoom in. I definitely need to zoom in. I think this will work. Yeah, because I'm using the React hook form, and I'm also sharing. This time I'm not. For example, sign in with password form schema. So I split up the input schema with the form schema because I have the TS token, the turn still token. And the turn still token is like a reCAPTCHA, right? And I also pass it down to Supabase. And yeah, that's what I'm doing here. Oh, a whole bunch of subscribers. Thank you all for subscribing. Yeah, and because I am using turnstill as I'm passing turnstill into the input of the server action, I ran into some issues because if I'm sharing the ZOD schema between the server action input and also the form validation schema, I needed to also put the turnstile token inside of the form. But I am, like, if you scroll down, I'm still, constructing the form data manually. So I decided to split those, right? The form itself does not need to be aware of the turnstile token. And I'm going to be sending the turnstile token like this. So we have error, email, and password, and that's it, right? And here's the server action. Await sign in with passwords, and I get the data. So if I go to this server action, we'll say that, it's using the base procedure, which sets up all of our services for us. We go in, we'll see here's the collection repository, and here's the collection service. There's the authentication service, and I'm returning both those values back to the action so I can, pull up anything I want from the context, right? I need the collections context. Sure, just, deconstruct it from the context. That feels okay. And we define the input with the input method, but then we also have an output method, right? And it's literally the same thing. Sign in with password output schema. And all I have is an object that contains an errors property, right? Which is an object. And in this case, it's going to be an email and passwords, right? And then if I go back, and I believe this can be made like a generic errors. So it returns an object with arbitrary keys, something like that. But yeah, I split it up just so I can have like good typings and predictable typings, yeah. And that's the output, right? At the end, I'm basically returning res, and I should not be doing this. We'll talk about that last when we talk about error handling and throwing, and which part throws, which part catches, and how the UI, the client gets to know about these errors. But yeah, basically, inside of this service itself, sign in with passwords, I'm using Supabase, and I'm getting these errors anyways, right? And by the way, here's the TS token, sending it off to Supabase directly. And this is just for, just for captcha, for, bot prevention, etc. Because it's a form, right? And if there are any errors, I'm basically returning them. So the return type of the service method is going to be either nothing or an object with the errors property. And in this case, I'm just setting the email and passwords to the same error message. And it looks a bit weird. Let me show you. It looks a bit weird, but I'll figure out the UX side of things later. Right now, okay, I know why. There we go. We didn't change the resolution. So this should be a lot better now. Nice. So check this out. If I try to log in, and let's pick this one, for example, and hit sign in, you see that? Invalid login credentials. That's basically the error.message. And I'm just returning that error.message, both for the email and passwords. If you want to show one message, like, I don't know, above the sign in or at the top right here, you would just return one single error or something like that. In this case, I was like, okay, just return it for both email and passwords. And that's what res is in this case. It's either undefined because it's a, nothing got returned, or it's an errors object with email and password. And I'm returning them in case, there are errors. So if there are errors, I don't need to revalidate or redirect anything because apparently we're not logged in, right? So just return them. And let's go to sign in form. Yeah. When we return them, because we have these defined into using the output method, we receive an array. And I'm not sure why this is. I think this is ZSA API, but we're receiving an array where the first element is the actual output. You see, we are right now in the client. We get the errors back from the action, and then we can just, if we receive errors, reset the turnstile token, set the errors to the email and password to the form itself so that the form can display the errors. That's about it. I'm not sure if there's like a second argument. Yeah, probably. It's of type ZSA error. So maybe this is like an exception type of thing. Let's actually try that. Let's do exception in this case. And we can debug this. Let's do exception. Let's go into the sign in with passwords. And here, instead of returning the results, I want to throw. Yeah, something bad happened. So now we have an issue here. Undefined is not assignable to errors. Yeah, so because if we throw, we need to do this now. If we throw, we cannot return. And that's why we're not gonna have an output here. Okay, I'm gonna go here and I'm gonna launch the app using the debugger now, because we wanna get there. Also, I want to add a breakpoint here as well. Here. Cool. So if I just go refresh, type in a user that does not exist, we're gonna hit this this point right here, and we can see that res.errors res should be, it's an object that contains errors, invalid login credentials. Pretty much the same thing, of course. We didn't change that part. But now we're throwing an error. And if we continue, we should reach the sign in form. Let me see if I can navigate it this way. Yes, we can actually. Can we? Maybe we cannot. Sign in form. Yeah, I guess nothing happens. I guess that's not the case. If I just throw something, let's check that out again. And I'm going to disable. Go back to auth actions. I'm going to disable the breakpoint here. I'm just going to hit this again. Let's see. It's always going to be 200. Okay. That is, I guess that's like the negative side of server actions. It's not like a traditional HTTP call. I can't just like return. I can't return like an 500 or something like that. It's always 200. Okay, I guess, right? Maybe there are like Next.js ways to return not found or something like that. Let's see. Yeah, this all looks. In this case, except returns an error object. In this case, except, you think so? Because we added. Let's try that again. Oh, we actually didn't hit that breakpoint. Okay. Let's see, output is null exception. Yeah. Exception does that. Internally has the error handler. Yeah. Okay, so there we go. We don't even, if we wanted to, we can define that. If not, I like that, I like that we can grab any errors. Nice. I like that. So yeah, we do have an exception handler built in by ZSA. And we can use this now to just display stuff. Let me actually zoom in this part as well, because I realize it's a bit smaller. Yeah, it has an object, that error. Yeah, thanks FTA. Yeah, this is good actually. This is good. So we don't need to always define the output to handle the errors. We can define something like this. And there's also data. And let's go to zsa.vercel. And let's figure out. I guess we're starting from the very end because error handling was supposed to be the last thing for today, but let's flip it up. Let's talk about errors. There we go. Granted, I did not read the whole documentation. Also work for Zod validation errors. That's even better. Let me see. I really want to try that. Okay, so we're not returning anything. Let's do this. I'm gonna get here, and for the errors, I do not want to define any, output schema. Hey, Sebastian. Thanks. All right, so we're gonna have some noise going on in the background. So apologies in advance. This is just like maintenance that needs to happen. All right, so we remove the output. Let's go back to the form. And now we can see that the output is non-existent, right? We do not define any output. Output is null. There's the exception. And the exception is a consistent type that has a message and also has data. There it is. It has data, it has errors. But the error itself also has data. Let's see. There's also a ZSA error, and I guess it's fine. I guess it's fine using ZSA error inside of the action because the action itself is ZSA, right? We're not mixing stuff. There's a whole bunch of error codes as well. Interesting. And ZSA also provides a typed version of the ZSA error, class ZSA class called TZSA error. We're using database session for auth or some third-party service that runs on JWT. I'm using Supabase. Yeah, our authentication service right now runs on Supabase. Yeah. Okay, we have field errors, form errors, and formatted errors. If the error code is input parse error, that is basically the input schema. Thanks, FTA. Yeah. The TZSA error instance will have an additional properties that provide information about the validation errors that occurred. So here's how we invoke the action. We can try if there is an error. If the error code is not authorized, sure, go for it. If it's input parse, then we have the field errors, form errors, formatted errors, all these types of things. Cool. Okay. Let's check this out. Output is not going to have errors. This is going to be data. This is going to be error. So if we have error, if we have an error, we want to do error dot message, but I believe it's always going to be the case. Yeah. So I'm just going to remove these. And instead of doing output.errors, I'm just going to do error.message. And we'll figure out. And data, of course, data is defined here. We don't need data. We don't need to define it. So I'm just going to put an underscore there. Okay, this looks good. I want to see what the error is. So let's go back to the auth action. And instead of throwing a, basic new error, we're going to throw a TZSA error. Right? That's how we were supposed to be using it. Yeah, throw a new TZSA error. Let's see. TZSA error, but it should come probably from ZSA. There we go. TZSA error. And this is a type. All right, so I believe we're just throwing a ZSA error. We should not throw like a TZSA error. This is, yeah, this is what we want to bring in. Yeah, and now this is the, there we go. We have all of the, statuses mapped out, the error codes. Nice. So for example, if we receive errors from the authentication service, it might mean, let's see how we can handle this, because this is, for example, in this case, sign in with passwords. This is going to be an authentication error. It's going to be like a generic error. We have a name, we have status, message, this kind of things. Stack, cause. Yeah, so we can like throw it, rethrow it. And I will also use Sentry in this case and like send this error to Sentry so I can check it out later. Because I can see it has a stack, it has a cause, yeah. So I would throw this. This is an auth error. I believe this is okay. Like we can just return or throw. Let's see. Just throw a string, of course. The data is whatever we throw, the message is that, and the code is just a generic error. But we can also, yeah, we can also throw not authorized. We already went through that. These are the error codes. Yeah, so this should throw, I believe. And this should throw whatever the error is from this side, sign in with, because we're going to be mixing things, right? This error is of type Supabase, right? The error itself is defined within Supabase. And if we throw the same error here, what we should do in this case is do like a try catch. And then based on the type of error, handle it. But the type of the error is going to be like an auth, right? If the type of error is auth error from Supabase, right? Actually, not type of, if error is an instance of authentication error, that's where inside we get these things. But check this out. We have a Supabase import in the service layer, and we don't want to mix those things. Stop by just to say that your content is really good. Congratulations. Thanks, Bruno. Appreciate it, man. Yeah. So we don't want to do this. This means, right, solid principles. I believe the S was a single responsibility. And yeah, this should not happen. Like we should not have dependency from the service to the database, right? This is the database. That's why I mentioned in the previous episode that we should probably define our own errors. And it does seem like a tedious job, you know, just redefining all the errors. But in order to keep things separate, we have to do that. One, I mean, look at the options. First option is to just throw the authentication error, and then we have to import it here. That's not good. The other way is to just go into the sign in with password and throw a ZSA error here. That's the same thing, but just on a, from a different angle. That means we're bringing ZSA into the persistence layer. Again, we do not want to do that because ZSA is ZSA, and it's only useful in the server actions context. But what if we're trying to sign in? But I don't know, like not sign in, but what if this is an API, like a route handler enabled functionality as well? That's not going to use ZSA, right? But we're reusing the same sign in with passwords. So we need to have a good split between these. And the only way, I believe, the only way to do that using errors is to either like return a specific, I believe that's going to be the most, like the simplest approach, just return something. But shouldn't the persistence layer throw and the error should like bubble up? I believe that would be the right way to just define a custom error and exception and throw that exception. And whoever wants to handle it, they can handle it, right? For example, this is the persistence layer. We don't care about UI. We don't care about how exceptions are handled. We should just throw them. I believe that's the right thing. A whole bunch of subs. Thank you all for subscribing. Yeah, I believe that is the right thing. Define our own custom errors so that we keep the layers, separate. We don't put ZSA into the database, and we don't put database into the server action. That's definitely not correct. Oh, this is the service layer, by the way. It's not the persistence layer. Yeah, but still, yeah. I'm using Supabase here, and we talked about this. I'm using Supabase here into the service, and we're not using Supabase as a database. In this case, we're just using Supabase as an authentication service, right? I'm using one service inside of the other service. It's a bit confusing, but yeah. So yeah, we're not using databases here. We're using services in the service layer. That's why I think we need... Interesting. Yeah. It has to be our own error. I mean, that's if we want to, if we want to keep everything separated so the layers do not use their own implementation, and implementation details. We definitely need to do these things. And I know it's... I don't like that I have to do this, but then on the other hand, being lazy is not good. So I would say, yeah, define on errors, throw on errors, handle on errors. I would say that in this case. Mutukumar, can you share the source code? I'm not gonna share this one, but after the whole live streaming series, I'm gonna create a demo app, still the same, same stuff, without all the noise, without all the, all the stuff and all the APIs, but just the clean architecture / layered architecture. It is layered architecture, it's not clean architecture. So it's gonna be only the demo app without all the noise, and I'm gonna release that one. So that's the source code that's gonna be available. Bruno, I think it wouldn't be a problem to have your own custom error navigate through all the layers. I think that's the right way, yeah. The problem is to have a specific error from, let's say, persistent library error navigate to presentation. Yeah, it can tie the layer together. That's what I'm referring. I can't just throw an authentication layer an authentication error that comes from a specific library. That's where we mix things. That's why we need something of our own. The laziest way is to just return an object, but that is not correct, right? And since I'm going to be using Sentry, I need an error to be reported. That's why. So I'm just gonna, I guess we have to define our own errors. There are no shortcuts in this case. So we'll do that. Sign in with password. So then we can do try and catch, right? And then we're going to do if the error is an instance of that type of error. And look, I think that's, let's see, effect.website. I think that's like how effect does it as well. It just provides, good typings. Yeah. So this returns an effect, and this is the data that it returns, and this is the type of error that it can throw. But like handling the error was also, let's go to the docs. Error management, expected errors. This is a catch-all. We don't want to do a catch some errors, yeah. Yeah, same thing, right? It's like catch some, and then inside, based on the tag, if this is a foo error, do this. If this is a bar error, do this. Well, there it is. If the error is an instance of our own type of error, we'll do this. Otherwise, we'll do that. That's basically the case. So we need our own custom errors now. Because like ZSA is cool, and we can throw this. Should we throw this? Because if we throw this, that means we're coupling ZSA with the UI, but it is coupled anyways. Like, check this out. If we go to sign in form, actually it's not right. It is not. Yeah. So sign in with password is the action itself. But look, this is fine. ZSA is a server action, and like we treat that. We decided to treat server actions as part of the presentation layer, along with the UI and along with the pages and all. Right, we have server components. It's on the server, right? It's part of the backend officially. That's where it lives. It lives on the backend, but it's a server component. That means it does presentation functionality. So it is in the presentation layer, and that's why I think we should be okay if we throw ZSA errors from the action, because the action itself is a ZSA action, and whoever handles that action must adhere to the API that ZSA implements. So if we throw ZSA errors from the ZSA action, that's fine. But if we throw any type of if we throw a ZSA error from the service, then we have a problem. So I believe we should be okay in this case, throwing ZSA errors. Or like rethrowing them. Yeah. Yeah. Yeah, so this needs to be, I guess this needs to be like a custom error. Yeah, it'll make things more complex. Yeah, so this will throw a generic error that we define, and we need to convert that error into a ZSA error so that, ZSA handles that properly, because it is, that is the library that we're using. So I'm gonna remind myself how we created our own errors. Let's see, TypeScript custom error. I think it was like class your extends error. Yeah, custom error extends error. It has a constructor get error message. Cool. It just needs to extend from error. And I believe, let's go to eraser again. I need to log in. Cool. We did this last time, and we have the DTOs here, but I believe aside from DTOs, we'll have errors as well. Errors are gonna leave, they can go into presentation, they can go into business layer, they can go into persistence layer because they're just errors, aside from DTOs. So far, we didn't look into, did we look into creating DTOs? Actually, yeah, we did. Yeah, but we need errors now. So let's go back out. We have DTOs, repositories, services, and this utils is like Supabase utilities. These are not necessarily a layer in the architecture. They're still there. I need to find a suitable, I need to find a suitable location for this folder. But here's our app, and which is basically the whole presentation layer. DTOs are all shared. Repositories is the last layer, the persistence layer, and in the middle we have services. That's the 3 layers that we have from the project perspective. Yeah. I guess we can have like a shared folder where we keep DTOs and errors and stuff like that. Yeah, let's try that. There we go. Checking for update JSTS import. So we have DTOs now inside of the shared folder, and let's also do errors. And first, let's define this type of error, and this is the authentication error, right? And the authentication error itself, I'm actually gonna open it from here. Error dot, it's gonna have, of course, I think all errors, when we extend from error, they're gonna have like a stack and cause, probably. But there's a code, name, message, and status. HTTP status code that caused the error. Okay, yeah. Should we? I'm thinking if we want to have like a generic error or just like try to replicate whatever's in the Supabase authentication error, but just like bring it to in our implementation. Yeah. There we go. So we have our own authentication error that extends the error class. And we can define like status codes and everything. Constructor is the message. We pass on the message. Let's see what the error class, the interface looks like. So it has a cause. The message is, there's a message and there's like options, which has the cause inside, but there's like no status. That's on us. So just message and cause. And I believe that's also what this error had. Stack and cause. Okay. Name, status, and message are all custom defined from Supabase, but probably, yeah, cause is the, oh, and messages, yeah. Cause is an optional field that comes from the error. Name, message, error, stack, yeah. We should check the, like the source code, but I guess that's pretty much it. Yeah, so we'll get the message. We'll call the super to pass on the message. We might even have like an optional yeah, let's bring in error options as well. We have the message, we have the options. Yeah. So far, so good, right? Let's say that that's the case. And I'm not going to throw... Hey, how's it going? I'm not going to throw this error. I'm just going to convert this error into our own errors, right? So let's bring in here. Shared errors. Authentication error. There we go. Let's bring that. I'm just going to throw, instead of this one, I'm just going to throw a new authentication error, but the one from our own, and we'll just do error.message. And then for the cause, we'll do, come on now, error.cause. There are also like other stuff like status codes and things like that. So I'm gonna put a breakpoint here on this line. We're gonna try to log in with wrong username and password, and we're gonna just like inspect the error, and we'll see what type of data we receive. Okay, this is here. I'm running. Yes, I'm still running the debug service. So we are throwing this here. What about the code? I know. Yeah, I want to see like what's inside of here, because I guess we can like, yeah. Let's also add the code. What else was there? We had the status code. There's a name. Error code associated with the error. Most errors coming from HTTP responses will have a code. Though some errors that occur before a response is received will not have one present. In that case, a status will also be undefined. So status can be undefined as well. There's a code and there's also a status. I don't know what's the difference between these two. Is this like a special code? Yeah. Let's just let's get the status as well, and that was gonna be either, I think it was a string or undefined. Now we have the error options here that they have the stack, but we also need the status, which can be undefined. They use the code to identify real cause, but do they have like their own type of codes, or they're like status codes? Because that's what I'm thinking. The code would be like a library specific error codes, but the status would be like an HTTP status. Yeah, true. Yeah. Okay, so we can also pass the status, and we'll see what kind of methods we want to, you know, export or define from this. There's to JSON and stuff like that, but so far so good. Okay. And here we also want to pass the error status. Oh, it's a number. Okay, fair enough. There we go. Now it's happy. Yeah. So the error code is, yeah, P1001, can't reach database server. Yeah. Yeah, like a library specific code. Okay, we're here, sign in with password. In this case, we already have authentication and we will just bring it from our shared errors. So we're catching this, right? Report to Sentry, but also we should return, or we should throw a new ZSA error. This is what I don't like about. Yeah, I'm gonna be honest. I don't like this, but I believe we can make it. We should be able to make it better, right? Yeah, this complicates things because we want ZSA. What is a ZSA error? A ZSA error is an error that is defined by the library that I'm using to define the server actions. And because it only lives here inside of the server actions, we can't throw ZSA errors everywhere, right? We might have like an API or like route handlers that use this very same services, but they don't use ZSA because they're not server actions, they're like route handlers. We're gonna have an issue if we throw ZSA errors everywhere. That's why I thought maybe it's a good idea to throw the define our own error and like throw our own custom errors around. I don't know how I feel about this. This is very manual. This is very like it feels like boilerplate. Feels like boilerplate code. Because what if this auth error, like it can be like invalid credentials. It can be something like I don't know, like user does not exist maybe, or something like that. I don't know. And we need to map that into a ZSA error now. Maybe creating your own auth error to throw in any auth. Let's see. Context, in any auth context or method. Hey Cody, love your channel vibe. Thanks, man. Appreciate it. Bruno, maybe creating your own auth error to throw in any auth context or method. Well, that's the thing. Yeah. For example, we have ZSA, right? I feel like we should throw a ZSA error so that ZSA can handle the error properly. So we don't need to map or convert in every catch. Glad you are implementing clean architecture as well. Yeah, honestly, you were a big influence in this. I was like, yeah, this looks cool. I wanna achieve that. So let's see how far we can push. Because it's not C#, right? It's JavaScript, but yeah, it's fun. And also, thanks for making that content. It's really helpful. Man, this is exactly the way affect pipes errors, right? Yeah. How begging CA skip the DTOs and DI. We do have one, we do use DTOs here, for example. Let's see collections. Yeah, there's a collection DTO just so we don't, I'm using Superbase, so I don't want to bleed out Superbase stuff into the service layer. So I'm just like, yeah, let's just define a tiny DTO here. And yeah. Can you show us how the ZSA response look like? Check this out. Sign in form. ZSA response looks like this. Looks like this. Yeah. We have form errors if the type is of a specific type. But there's like a name, a message, data, a code, and that is the ZSA type of code. And if the code was, where was it? Input parse error, it's going to have field errors and formatted errors and inform errors as well. And we can take these, like form errors and field errors, and map them to React hook form, just so, ZSA and React hook form talk to each other, right? If the email, if there's an error in the email field, it'll just throw that, show that error in the email field. But that's that's the ZSA error. And because we're using the ZSA library to create the actions, we are gonna work with these ZSA errors. And if we work with ZSA errors, we need to throw ZSA errors. And ZSA errors are server action specific errors. But behind the whole thing, behind the whole server actions and everything, we have generic, unlike framework agnostic services and library agnostic services. They're just like plain JavaScript, right? And we also have a persistence layer, so we cannot put ZSA errors in those layers. They need to throw their own errors, but we need to convert those errors into ZSA errors here, just so we can let the UI know, right? Because if we use the same services and repositories in different parts of the app that is not a service section, we can have ZSA errors there. So I believe we need a mechanism in this place to convert like our custom errors into ZSA errors, and that's going to be used only in form actions, right? It does make sense for form actions to throw ZSA errors, because that would be the best, the easiest way to let the UI know of any errors. So I guess we have to build a utility function that will convert an auth error into a ZSA error so it can be thrown. That's the thing. And let's check the constructor. Maybe you can extend the ZSA errors on author. What do you mean? Yeah, there's the code and there's data. And the data is unknown. It can be anything. It can be a string. It can be an object. ZSA will take whatever you pass as the data and it'll just send it back to the client. And there's also input parse errors, output parse errors, and we don't set these. These are the Zod schema errors. ZSA will do that for us. We just need the message and any data that we want to send. So there's literally just two properties. But we need to map authentication error into it. And authentication error itself is pretty vague. So maybe this is our issue. Maybe authentication error should not be, as vague. Maybe we need, more specific errors, like invalid credentials error, or user does not exist error, something like that. In that case, if we have that, and if the error is an instance of invalid credentials, then we know what we want to return back. Hopefully. Yeah. Let's see. So we have input parse error, and that's being done automatically. We have output parse error. Again, that's being done automatically. A generic error, not authorized. It can be used in that case, right? We have a timeout internal server. Again, it's just a regular error. Forbidden, not found, conflict, precondition, failed payload, too large, method not supported, unprocessable content, too many requests, yeah. Payment required, insufficient. There's like payment required and insufficient credits. Okay. It has like a little influence with payments and credits and stuff like that. That's cool. Yeah, and this is what happens on the client, and the client should remain like this. It should, yeah, the client should handle ZSA errors. But what happens in the backend? We should just like connect these. Yeah, I guess that would be the case. Instead of a generic auth error, we need a specific error, an error that is more descriptive than there's a problem with authentication. Of course, there's a problem with, if we're in the catch clause, there is a problem in the authentication, you know, in the authentication operation or whatever. What is it? That's how we can, map out stuff into ZSA errors. So ours will be more granular, more precise, and the ZSA error will be a ZSA error, I guess. What is the superclass of auth error? Of our own, it's just an error. And we should keep it like that, right? I think Mehdi suggested that we do, let's see. You extend ZSA and do the converting there. Instead of extending error, you extend ZSA error. Yeah, we should not extend ZSA here, because this authentication error is gonna be used outside. Like it's gonna be used in services and stuff. Have you tried using the shape errors? You could potentially look for any type of error that extends public error, then allow the UI to see those messages. Shape errors? Let's see. Oh, shaping error objects. We should just read the RTFM. RTFM. Thanks, Cody. Let's see. ZSA provides an experimental feature that allows you to shape and customize the error object returned by your server actions. Beautiful. This feature enables you to include additional information or modify the structure of the error object to better suit your application's needs. Yeah, it's an experimental, and we may change the API in the future. It's cool. Shaping error objects. To shape the error object, you can use the experimental shape error. Oh, interesting. When creating a server action or procedure, this method takes a callback function that receives an error, the original error object, presumably that we throw from where? From the handler. And type data, an object containing the parsed and raw input data. The callback function should return an object that represents the desired shape of the error. You're probably going to define your shape error functions before TypeScript will have access to the input-output schemas of your action. To get around this, you can use the typed data object that is passed to the shape error function. Okay, but this is an experimental feature that allows you to shape and customize the error object returned by your server actions. Yeah. Okay, so basically we can, whatever's thrown here, I believe, whatever's thrown in the handler, or it could also be the inputs, right? We have a Zod schema there. It can be like an input parse error as well. I don't know if it helps what you're trying to do. I have my use cases throws error defined in my business layer, and I catch and convert to a different type of error so the UI can display it. Okay, so like I believe your use cases are my services. I think that's like, we have like pretty much the same thing. You throw, let's see, you're trying to have my use cases throw errors defined in my business layer, and I catch and convert to a different type of error so the UI can display it. Okay, so in this case, like my errors are defined in like a shared folder, and I believe that will be the issue there. But if we're throwing, let's say the auth error was defined here, you're throwing it from the service and you're catching it in the go back to the action. So to say, yeah, no, I guess that's the case, right? You are converting it to a different type of error so the UI can display it. And are you using the ZSA errors, or yeah, Yeah, so that's why that's why we created the auth error. And I want to convert the auth error into a ZSA error. I believe that's the way to go. Would you mind if I share my repo and you can take a look at how I did it for an ongoing project? Yeah, of course. Of course. You can share that. FTA, I refactored one personal project following the episode 1. I also skipped the DTO part, but I kept the service interface repositories. Yeah. How did you handle the... if you skip the DTO, how did you handle returning stuff from the repository? Right, for example, create collection, right? It uses Supabase in this case, and it should return... a new collection, right? If you return Supabase type, then you're mixing these things, right? That's why I put the DTO in place. Just, regardless of the shape or the library here, collections are this in our app, and this is what we work with. Yeah. I just learned about ZSA. Yeah, I guess we can like figure this out. This has to be it. Yeah. These are custom errors, but I guess I'm fine with having ZSA errors in the UI because we are using ZSA in the UI, right? We're not breaking any rules if we handle errors in the client, in the browser, the ZSA way. So I guess we should be good. That seriously, this looks like define the author, convert it into a ZSA error, and throw it, right? If we're using this service in a different part of the app, in an API or whatever, it'll just be an auth error or whatever it is. Yeah. So let's go back here. And here we have an error. And that error has like a status and something like that. I make a video on ZSA. I will watch it after reading the ZSA documentation if I could not understand anything. Yeah, I guess I skipped the DTO part because I missed something. Could you show the from DB method? From DB is literally, let's see, collection repository. From DB is a static method that takes in a collection type. Where is that defined? Yeah, it's in utils types. And it returns a collection DTO. And you're using this, basically. And the collection type is defined from Supabase. Yeah, it makes refactoring your business layer easier. Yeah. Yeah. Would use entities and DTOs. Correct, yeah. So that's the collection is defined from Supabase. Is defined from the database, right? So it from DB receives a database, a DB specific type, but it returns a DTO that can be used, outside of the persistence layer. So that's all. That's from DB. Save this. Let's see. I moved some stuff, so I need to save all of these things now. Save, and one more sign in form. Yeah. Okay. Auth actions. We should go to sign in with passwords. And now this is where we throw our own custom error. And I think we should be more granular than authentication error, maybe. Can we map this? We have a status, we have a message, and we have a cause. I believe we can. Let's go to auth actions again. First, we had the code. So that's going to be error dot our own error dot status. But status is a number. See, yeah, that's what I'm talking about. we have error codes here that are defined by ZSA. So if we want to throw a ZSA error, we need to convert somehow. And they already have that. They already have this type. See? ZSA open API. So, but this is open API. This can be used when returning errors from an API endpoint. We do have these numbers. We need like a switch that reverts that and returns these status codes based on the HTTP code that I'm gonna pass it to. So that's the case there. Yeah. We're gonna need something like that. And this is like a different package, I guess. ZSA Open API. Let's check it out. Open API, source. It's probably in the utils. There's the error to a status code. Yeah, but there's not a method that, converts a status code into a ZSA error code. How do we do that? Like, of course we can, define our own switch, but then we need to maintain that in parallel to ZSA. So if ZSA does any changes in the way that they handle this, we need to immediately update our own. I don't believe it's actually worth to convert. Yeah. What if we actually try I think we should try like the custom errors that return a code, a message. We have the code. We have the message. Yeah. Yeah, we are gonna pass like the actual error to Sentry. But the ZSA error is like pure UI stuff. So look at the repo. Later. I don't see the repo. I think I can, like, you can send links. Try sending it in my Discord. Yeah, the ZSA error thing is just purely for the UI. We don't like. This is just a way to let the UI know what happened in the server action. And ZSA do have this interesting ZSA error, but like, how can we hook up auth error with ZSA error? It has a number, it has all of these things. Yeah, I believe we have to. Because even here, we have no idea what the status might be. So we don't want to. Actually, I guess even if we like split it up and go and be more granular when we're describing the errors, I feel like this is where it should be. You know, if the error exists, then check out the status code, check out, you know, based on this, throw different types of errors back into, we're in the service right now. So the service should throw, you know, multiple types of errors, not like a generic auth error. If we do that, check this out. If we do that, we're going to have multiple, you know, like if statement here. If it's of type this, we can easily map it into ZSA error. If it's of type that, damn, that is exhausting. That is truly exhausting. Let's see this. What if I just do error like this and then pass whatever's in, you know, whatever's in the authentication error? What if we do that? Internal server? No, it's an error. Because this is this is only for the UI. That's it. It's only for the UI. If the input is wrong, we won't even reach that point. So this is only sign in with password. If it can't sign in, then there's an error. It's not not authorized, right? It's a different type of error. Of course, we're not authorized. We're trying to, you know, not authorized is like a different different type of. But yeah, I guess we can just stick with generic error and that's it. Yeah, generic error and that's it. And then what was the constructor? First it was the code, and then we had the data. Then we had the data. If the error data is an instance of the built-in error class, which it is in our case, the ZSA error instance will inherit the message, name, and cause properties from the error data. See, it's here. We have our own custom error. We are extending the error class. We can just pass that as the data, which is the second argument. So I guess error, that's it, right? That's what it says. If we pass in an error from the, you know, an instance of the error class, which it is, the ZSA error will inherit the message, name, cause, and everything else. I feel like this is gonna work. I feel like this is gonna work here. It was right there, right? Okay, let's go to sign in form, and we need a breakpoint here, and I try to set a breakpoint here, but it never actually triggered. Yeah, we're still running. We are. Let's go and see what's gonna happen. Sign in. The error. The data is status 400, and the message is in invalid login credentials. That's what we throw. And it's the generic error code, which is fine, you know, no big deal. This is the data that we sent. And that thing right there is our authentication error. It only has the status. Right, the message is sent to the error, and any other options are sent to the error. The only thing that's different is now the status, and that's where we have the data inside. Status is 400. So if we like parse it, json.parse error.data, there it is. It's right there. Okay, so I feel like this is going to work. Right, we're throwing errors, and that's it. ZSA makes sure that, you know, no No sensitive stuff leaks to the client, like a stack trace and stuff like that. So that's good. That's good. Okay. It is it's a lot better now, to be honest. Yeah, and then the UI can, the UI can handle. Let's see if we can error that message. Of course, invalid login credentials. Bam, there we go. So we're still reporting the error to the UI correctly. Okay. Okay, and we'll just, because we have an error, we'll just report the error to Sentry so that we can see how often it happens, etc. Nice. There's the catch, and we need to move these here. If there is no errors, revalidate the layout and redirect. Do we need to revalidate? I believe we don't need to revalidate the layout on slash. We just need to redirect. Probably not to slash. I would just redirect to slash app. Slash app. Let's try to log in. Slash app slash collections. Yeah. There we go. Let me try to log out and log back in. I'm gonna try this. I believe this was the correct user. Nope. So I do not have an account with username password, but still, yeah, it's just gonna go to slash app slash collections, which is like the dashboard. You would just send the user whatever you wanna send them after logging in. And if something happens, we report it to Sentry and we throw a ZSA error that inherits everything from your own custom errors. This is fine. This is good. I believe the error code would be like a default error. Hold on, I think the default was server error 500. And you see that when you pass in the error, it's by default is the internal server error, or it's the output parser. Okay, so it doesn't matter. The error is still 500. Cool. It's all cool. It's all cool. This is gonna work. This is gonna work, and now we have our own authentication error that we can just throw, and if it's a server action, we'll handle it with a ZSA error because that's a UI thing. If it's an API, we'll handle that through a response with a correct HTTP status code, etc. Nice. Nice. This is good now. This is good now. Yeah, there we go. We have custom errors. ZSA errors helps us, notify the UI, but everything else is our own custom authentication error, and we can put any type of data that we want, and we're going to create our own specific errors moving on, so that we don't use libraries like ZSA or Supabase where we should not be using them. That's good, yeah. So the only thing that's left for today is to figure out how we can set up these services, and check out how I have the services set up. All of my ZSA actions are being created from a base procedure, and this base procedure literally just creates a new collections repository, creates the service, passes the repository to the service. Then we have an authentication service, and I return everything. So the negative side is that we're going to create all of these things, keep them in memory, and then return all of them, even though we don't use them. And the other negative part is that this will work only for server actions, but not for pages and stuff, because we do. Let's say there's a fingerprint page, and this fingerprint page, let me show you, is, for example, when you open a collection, you have like a bunch of links inside. When you click on the view collection page here, it will show you like a link tree type of page, right? You have the website, you have Twitter, you have your links here. In this page, we have no authentication. I mean, we do, but not necessarily, right? Because if I were to open this in an incognito window, we can only see YouTube channel, not X and website. Why? Because, let me zoom out now, because they're not visible to the general public. I have them here. I just don't want them to be visible on that page, right? The only authentication is that. Should I show this or not? If you're authenticated and the collection belongs to you, you'll see these links. If not, just show whatever's visible. That's like the public. And what is that? All right, something bad happened there. Check it out. Here's the public collection page. We take the parameters from the fingerprint from the parameters, and this all needs a lot of work, right? We have Supabase directly in here. We're trying to query the collection. If there is no collection, we also try to query the links database as well, because fingerprints are just fingerprints. They can belong to a collection or link. If it's a collection, show the public page. If it's a link, we want to do a permanent redirect to that link, right? And then I'm gonna have like a implement analytics here, if when we reach that point. But this stream is not about the app. The only thing that let's see, we need to refactor this whole thing. It's gonna be a service that the repository does this, then the service returns the data. It's all cool and all, but yeah, this is where we use. Yeah, this is where we're going to be returning all of this. So this is a page. This is not a server action, right? Therefore, we have ZSA procedures, but we should not be constructing all the the repositories, all the services. We shouldn't be putting them here. We need a different way to like construct the whole thing. And I was looking at some possible ways. One way is to just just do this, embrace it, do this, try and then like measure performance later on using Sentry to see if this has a significant hit on the performance. So for every page load or for every server action, is this a significant performance hit? If it is, we need to be, we need to implement something leaner. And I was looking into that. Two ways to achieve that: service locator or dependency injection like Inversify. Those were like the two things. And here's a service locator pattern. It's basically a lazy singleton. So these are your services, right? There's an initial context. Let me zoom in more. There's an initial context that has like a lookup, and this is in Java, okay? It has a lookup. It has like a lookup method that creates the services in itself. There's a cache layer inside as well. It keeps a list of all of the services, and it has a get service and add service. Inside of the get service, if the service exists, it returns it. If not, it returns null. And there's the add service. It's going to add it to the cache or to the list of services only if it exists. And then there's this service locator main class. It just keeps the cache, right? It creates a new cache, and then it implements the get service. So it's going to try to get the service from the cache. If it's not null, if it exists, return it. If not, create the context, add it, create the service, add it to the cache, and return it. So the next time we'll hit the return service. And here's like a demo. we get service 1, and it says creating a new service object, executing service 1. We're getting service 2, creating a new service 2, executing service 2. We're getting service 1 again, returning cached service 1, right? So for example, if we didn't use service 2, it's not going to spend any time creating it and keeping it in memory. It's only gonna, it's only going to keep it in cache only if it's being used. So that is a lean way, a more performant way and better way to handle this. But it's going to be interesting implementing this in Next.js, because Next.js can be like a Node.js long-running process, or it can also be serverless. And we need to keep this somewhere. Not sure if it's going to be like a huge issue, to be honest. Let's see, disadvantages. The registry makes the code more difficult to maintain, opposed to using dependency injection. Sure. I hate this part right here. The way that the services are being created. This is I don't like this part right here. Because the initial context will always create the service in the same way. And we implemented interfaces for the repositories just so we can like switch them for testing and stuff like that. That's like another thing that we should talk about in this case, but I definitely don't like the way that the initial context is defined right here. So that's one thing. And the other thing was Inversify, which is like a DI framework for JavaScript, for Node.js, for TypeScript, etc. There were a lot of like negative sentiment on Twitter about this. Hey, thanks for the sub. Thanks a lot. Yeah, there were a lot of negative sentiment. I'm not sure if this is gonna work in Next.js as well, because it uses the experimental decorators and emit decorator metadata. I think I've seen. Hold on, I've seen a repo that does this. Next.js Inversify. It was using the instrumentation.js file from Next.js to set up the dependency injection container and do the whole thing. Let's see. Was it this? Yeah, not a lot of content around this. Yeah, it's 2020. Next.js uses SWC, doesn't use Bubble or something like that. And I believe, I'm not sure if these two, the experimental decorators and emit decorator metadata, work with SWC now. Yeah, but I think this will be an overkill. Let's see, is this the... Yeah, this is old. I see, like 5 years ago, the last commit. So we're not going to be looking at that. Okay, yeah, we're not going to try to get into Inversify and stuff like that. It's in Next.js, it's weird setting it up. There's like there's a lot of catches. So we're not gonna try to implement it in any way. What I think that we should do is just, keep it simple like this. I think that's gonna be the best way to do this. create them manually, return them. Sure, we can have some like caching, or a caching layer or a lazy layer, but we should definitely just keep it simple like this. And then we'll we'll set up Sentry. We can measure the performance hit if there are. How to get the current session with this pattern? Supabase. I'm not using the authenticated procedure, but that's how, and this is another hole that I haven't solved yet, because sure, Supabase, it's in the authentication service. We are missing a method, but we would just get like get current session or something like that, and it would literally do this, or get current user, because there's like get user and there's also a get session, I believe. Yeah, there's also the get session from Supabase, and we can use this and just move it to a service. Yeah, but if you were to use a different library, it would just like implement that library and return the session and the user. Okay, so yeah, we need to move this out so that we can just use them into other parts of the app, and we would just invoke that into the procedure, so that the actions their access to the services remain untouched. That's all. And that's why initially it was let's actually think about this. Like, this is this is, yeah, in a way, this is like a singleton. If you're using this in a service in the authenticated procedure, you call that service because it's already in the context, right? Yeah. I mean, authenticated procedure contains the authenticated service. So I just need to move this whole block, actually these 4 lines, into the context, and do like ctx authentication service dot get user, instead of directly using Supabase here. But I'm just gonna refactor that later on. Everything is going to be based on a everything is going to be based on a service, and then I can just like keep using authenticated procedure without actually, because this is being used. See, I do use this, and then I'm also even returning Supabase and user, but I'm not going to return Supabase. I just need the context and also the user, so that actions will have the user object already baked in from their context. Yeah, we need to move this away in a place where it's just JavaScript, and it returns this. So let's see. I'm still thinking about this service locator pattern. Should we try doing something like this at all? Because, for example, inside of the initial context, based on the lookup, it will know how to create these services. But then check this out. We have service 1 and service 2, right? Our services can also accept a repository inside. So if this is a list of services, yeah. Yeah. This has nothing to do with actions. I believe we can like get it out somewhere. somewhere that makes sense, and then just invoke that function inside of this handler and return all the services. And then measure the, we'll do some tracing in Sentry, and we'll see if the, there's a lot of time spent in that part right there. Yeah, this is in the this is all in presentation layer. We need to get it out anyways. Repositories, services, we have utilities, and shared. Maybe we can. Maybe we should put the service setup here in the shared one, or utilities. I said that I would move this somewhere in a different place, because it contains stuff from the Supabase. Client, I'm not using this anywhere. Yeah. So I can just like delete it if I wanted to. Middleware is being used. And it is being used in the Next.js middleware, the update session. And server is all of the create client that you've seen so far. Types are just exported types based on the tables from Supabase. Also had the generic form state type, which I'm not using anymore. I can just like delete it. This is also not being used anymore, deleted. But the link and collection, these two are being used in the DTOs. In the client, you would be calling the ZSA action with the hook. Yeah. The clients and the ZSA action, they're like already coupled together, because I'm using ZSA on the client side as well. I'm using the hooks. So yeah. Okay, so we need a good way to place something that's, not resembles the service locator, but just sets up the whole services and, stuff like that. There's a middleware here. I'm still not sold. I don't know if we should like create all the services at once. Like if this is should we be doing that, Because if it's in serverless environment, and it is right now, I'm just hosting that app. Bfed.sh. I'm just hosting this app in Vercel, which means it's serverless, which means for every server action, all of the services will be recreated. That doesn't work. Even if it's just like, I don't know, create collection or authentication, like sign in. Sign in does not need the collection service and the collections repository and all of these things. It does not. So we shouldn't be, executing collections codes if we want to sign in. That icon effect is amazing. Yeah, this is matter.js. It's like a cool library. But yeah, I'm still not sold on that. ZSA procedures. Yeah, this is bad code. Like every procedure stems from this base procedure, even the sign in, like the authentication procedures, the authentication services. So we should not be doing anything that has to do with collections if all we want to do is just sign in, right? We do need like a lazy way to set these things up. And the service locator pattern was one of them, was one of those ways. But our services can also depend on repositories and stuff, you know? So I'm not sure if there are going to be any problems if we... I mean, there will be. I guess there will be. If we create a service and create a repository, but return the service, not return the repository, and just keep the service there, what happens to the repository, right? That's what I'm thinking. And if we create it once, we shouldn't create it like again for the second time. Okay, let's here's what let's like start from the very beginning. Service locator.ts. All right, I'm gonna stop the debugging session now because it's like becoming annoying. And I'm just gonna do npm run dev. Don't need to debug this now. Okay, export class service locator, right? It's not gonna have a constructor. It's just going to have let's see. Yeah, service locator. There's like a static method. It's a static constructor. So it recreates that cache. Let's see, TypeScript static constructor. I don't think there is such a thing in TypeScript, is it? Yeah. Do not have this feature, of course. You can still define a function statically and invoke it by yourself. Well, of course, yeah, but we're talking about classes. Initialize. Oh, okay. There are static block initializers starting from TypeScript 4.4. Let's see. Static blocks. Help you write more complex initialization code for static members. These static blocks allow you to write a sequence of statements with their own scope that can access private fields within the containing class. That's good. That means, because this is going to be our cache, we're going to have a static block that will initialize that cache, and the class is going to expose other static methods like get, service, etc. Yeah. Okay, so static blocks. Class foo does 1, 2, 3. Okay. Okay. So we're gonna have our cache here. We'll define a static block here that will it's gonna be like a record of string. Oh, in this case, the cache was an actual class, and it contained a list of services inside. And why don't we do this? Let's see. Initial context. Yeah, this whole thing, like, I don't know. Yeah, we get the gist. Like, basically, the cache is a list of services, right? But the lookup is by name. So if we want to compress that into one class, I guess we need a record of string. Man, is this gonna work? And any, and then we'll just, you know, break all the rules. This dot cache does not exist on. Oh yeah, it's not this dot. It's service locator dot cache does not exist. Yeah, it does. What am I missing? Oh. Okay. So this is let's say console.log setting up cache, right? So there's the service locator. This is our, you know, weird cache thing going on. And then we can say get service. We can pass in the name, right? And if the service, we'll say this dot underscore, is that gonna work now? This dot cache. If the service exists, we want to return it, right? Otherwise, we want to create it, cache it, return it. And then based on the name, we need a way to, you know, to create that and return it. Okay. I'm seriously, I have no clue what's going to happen with the, that would work in serverless environments. Well, it should, right? The first time that we invoke this class, when we say service locator.get service, it's going to create the cache, create the service, and return it, all during the runtime of the requests, right? And then the next one should not have this whole cache thing, because it's in serverless, right? It's gonna boot up like the whole, I guess this is, we're gonna see this. I haven't been in a situation, in a scenario where, you know, doing these things would I haven't been in a scenario where I've done these things, so we'll see, we'll figure it out. So in this case, we have the let's play it super dumb right now, right? Let's just like build a proof of concept. If the name is, and can we like somehow inherit the name from the services? Let's say authentication service. TypeScript get name of class instance constructor name, or my class.name. Okay. So let's bring in the authentication service here. Dot name, yeah. In this case, service is going to be a new authentication service, just like how we have this defined in ZSA procedures, like this. And then what I need to do is this dot cache based on the name equals service, or like authentication service. Yeah, let's authentication service, put it into the cache, and then return authentication service. That's all, right? There it is. Let's get service. So create it for the, only create it once if it doesn't exist. Let's try the same with the other, with the collections service. And I realized since we're pulling in stuff from the services, we shouldn't be, yeah, we should move this instead of the shared. We should just move it to the services folder, because that's where the, all the imports are from the services. Yeah. Now let me go back to ZSA procedures, and I'm just gonna do this. We also need the repository in this case. So this is where, we would have like differences. One of the reasons why I wanted to build this whole clean architecture and stuff, so I can, I can replace repositories in testing environments, or replace repositories in staging versus live environments, right? The live deployment will read from the, from the live database, but that's like a one environment variable. But in testing, we don't want to use the database at all. We just want to create a mock collections repository so that it returns some like plain objects. So we don't have a database during testing. Our unit tests do not need to spin up a database. So that is the one of the reasons, and that's why I separated these. Let's just make a note here. The place to how do we say this? The place to instantiate different is if needed. Yeah. Okay. Right now I just have one, but let's keep it like that. And then we need this. This dot cache based on the name is gonna be the collections service, and return collections service, so that the next time, we don't actually recreate it. Let's try this now. If this is all, we can go to ZSA procedures and basically just like empty it out. We don't need that. Oh, hold on. Let me just move that service locator. I'm gonna move it back into the services. Cool. So base procedure does not inherit anything, basically. I mean, it doesn't return anything. Here, it's gonna return a plain object just for now because we had an error here, but now we don't. We'll see if we're gonna do anything as like a base procedure, but let's go back into auth. There it is. So we are pulling authentication from the authentication service from the context, but we should be using our new service locator class now. Okay. So we're gonna do service locator. There it is. Dot get service, and that service is going to be authentication service dot name. Okay. Come on. This should be okay. So when we run this, I'm going to stop it for now. When we run this line, when we like actually try to here, console.log sign in with password. We should see that first, I believe. We should see that first. Then we should see setting up cache, and then we should see yeah, let's put some logs here. Exit is cached. returning the cached version. And then we'll do, what is the work of base? Nothing. Right now it's just nothing. But I don't want to remove it, because if I remove it, I have to, you know, like refactor the whole app. Okay, let's try this. There's a bunch of console logs, and these console logs will help us understand what is the flow, the operation flow of, you know, this service locator. What happens when do we hit the cache? When do we create the services again? And we're gonna try to sign in with wrong password twice to see if the second time the cache is being hit. But that's gonna be different on my laptop, and it's gonna be different when we deploy it on Vercel in a serverless environment. That's why we need to test both versions. Okay. Sign in with passwords uses the service locator proof of concept that we just built. Okay, let's see. Let's see what happens. There we go. I'm just gonna sign out now. Go to sign in. Okay, we saw setting up cache. But hold on. We want to start from the very beginning. Let's see. Oh, there we go. Setting up cache. You see that? So it's not... Yeah, let's have some fun now. So we have setting up cache here. Even though we are using the... we are accessing the service locator here, we actually hit the cache. So I guess that's good, right? If I were to, I'm gonna put it on this side, and I'm gonna put Brave on this side. Okay, if I were to refresh, we can see we don't see the setting up cache. That means the service locator, the static block, only got instantiated just once. This might not be the case in the serverless environment, because right now I have a long-running server, right? But we don't see the setting up cache anymore. Let's try logging in, and let's see what happens. Signing in with password, creating and caching authentication service. And it did that successfully because we can see the invalid login credentials, which is an error message that is, you know, that is returned by the service. So that's good. Sign in with password, creating and caching authentication service. And I know you can't see this, but here, creating and caching authentication service. Cool. Let's try signing in again. Oh, authentication service is cached. Returning the cached version. You see? Bam. 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 So our proof of concept works, right? We are returning the cached version. We're not recreating this all the time. But let's see. Hey, thanks for the sub. Let's see. Let's try to deploy this now. Let's try to deploy this. I'm really curious to see. I'm gonna try building it first. I'm gonna try building it first and see if like any errors so that it can deploy. Yeah, there we go. Of course, yeah. No. Damn it. No, it's still not in GitHub, the repo. I'm gonna be creating a different project that is much cleaner than this. This is just us figuring out. This is just us figuring out if, you know, if we can achieve the clean architecture and stuff. Okay. Let's see if that worked. Yeah. In a much cleaner project. Okay. Build succeeds. Whew. Let's actually push this. Work in progress. Testing, service, locator, behavior. Yeah, it's a really good structure. It's clean. All right, let me try this now. This is my project. Here it is. And we're just gonna open the preview branch, and there were logs. Yes, there were logs. So we can pay attention to the logs and see how this behaves in production. Can we create a CLI to generate this kind of structure? That is a really good project idea. Definitely a really good project idea. Like a scaffolder, clean scaffolder. Yeah. Yeah, generate service, bam. That'll be really cool. Okay. There we go. I'm gonna open the preview and I'm gonna go, actually, we can see the logs immediately here, right? Yeah. Nice. I'm gonna move this over to this side. And I'm gonna try so that we can look at the stuff. Ah, damn. I have an issue now. I have an issue now with, let me show you. With this. The TS token. And let me try to fix this real quick. If I can be quick about it, but yeah, let me try to fix this. I'm gonna go to turnstile. There's the, I can see all the stuff here. No filters needed. How did I do this? Oh, there we go. Settings. Okay. There's one thing, and the other thing, like it was vercel.app. I'm gonna try to add this domain to update. So let's see if, like, let's see how long it takes for this to actually refresh. If not, we're gonna push a fix for it, you know. We might need a fix for this. We might need a fix for this. So in the meantime, here's what we're gonna do. Hold on, let me see. Yeah, in here, in my project, I have an environment variable for the turnstile key. There it is. See that? So I'm gonna create a new one. But that's the secret key. Actually, there's like a different key. Yeah, there we go. This one. So I'm gonna create a new one. That will be only for the preview, and it's only gonna be on the clean architecture. The value is gonna be this because this is a testing value. And I'm also gonna put the key here. And it says that it already, yeah, it's just a warning. I'm just gonna hit save here. And I'm gonna take this now on this side and edit the actual one not to be on the preview. So in this case, we should have two of these. There we are. The test one is on this preview, and the actual one is on production only. So with that in mind, let's go back to deployments. Open our preview deployment. Yeah, you see that? Now it's success. Why? Because, of course, we actually we faked it. This is a tests key. So let's go to logs now. We should see some logs now. Environment. The host is always that weird branch name. But let's see. I'm gonna try to log in with test@email.com 123 123 123 123, something like that, you know. I'm gonna hit sign in. It says invalid login credentials. That means it went there and got back. But where are our logs? Oh, okay. Okay, we do see something. Are these based on time? Oh, 8. Okay, so the older logs are below. Setting up cache, sign in with password, creating and caching V service. There's the message, right? It's like one message, one log point, but we have 3 console logs. That's fine. Setting up cache happened, I guess, when I invoked the sign in, and then sign in with passwords happened, and then creating and caching V service. V is because it's minified. But let's hit sign in again. And hit refresh probably. Maybe I need to like hit refresh. I guess we should wait. Come on, let's go. OBS later when I end stream. Okay. Okay. Hey, look at that. Here's the second attempt. Sign in with password. We don't have setting up cache. That happened only once. Correct. Here's the sign in with password. Here's the sign in, but check it out. V service, and this is authentication service. Authentication service is cached, returning the cached version. So this tells us that, you know, the cache works. Yeah. This tells us that the cache actually works between, you know, between these functions. But how? This is a middleware. We can see that these are serverless functions. How is it working? I mean, I'm happy that it works, but like, how is it working? Let's try that again. This is interesting. This is very interesting. I'm gonna hit sign in again. And see what happens. I do not understand serverless. I thought that the whole thing was, building up from scratch and then tearing down when the request is finished. Yeah, I mean, it looks like that. Internal cache shared between invocation. Maybe on a different platform is going to be different, I need to wait for a bit more. But it's interesting. This is definitely interesting. We saw that it's basically the behavior in Vercel and behavior we saw in our terminal is the same, right? I wonder how, I mean, if we publish this, if we deploy this in a Docker container, in a, I don't know, in a Hetzner instance, I believe it's going to be pretty much the same. It's going to be one long running service. When we hit the service locator, the cache will get created, and that's it then. Come on, Vercel. We need the third invocation. Maybe we need some more invocations. Let me test one. Test one. Bam. Okay, load new logs. You see that? I don't know how it works. Maybe it puts them in a different place. Load them. There we go. Now we can see them. All right, so this is the first hit. And it says setting up the cache, sign in with password, creating and caching vService. But then sign in with password, vService cached. vService cached, vService cached. So yeah, there is the service locator keeps the cache between, it keeps the cache between invocations. I want to try one more thing. So we're in the first hit here, and we can see that the duration was 760 milliseconds, 100 megabytes of memory. We hit the cache now. 197, 112, 226, 125, 98, 95, 99. You see? 84. That's what I was interested in. Aside from the first one, which is 760, which is, yeah, this is the cold start, basically, most likely, because it's almost 800. But everything is set up, and then the cache is being, yeah, this makes sense. Yeah, the service locator in this scenario does make sense. I'm happy that it works, on serverless as well, because that is how people deploy nowadays. It needs to work for serverless as well, and it does. I'm not sure about the caching. For example, what if there's no usage for several hours? Oh, we got new logs now. What if there's no usage for several hours? Does that mean that the cache will be busted? And then when we try to make another invocation, then we rebuild the whole cache? I'm curious to see that. If I guess that must be the case, right? You know how Supabase will pause your server or your instance if you're not using that instance for 7 days and something like that. Maybe that is the way how Vercel will handle that. But nevertheless, even if that's the case, we can still see that, you know, caching is persisted between invocations, and I guess that was what was important to us. There is cache between serverless invocations. Maybe it's different between users, even if in that way you get the benefit because it's too probably you use the service many times. Yeah, exactly. I can try that now. I can actually try that, right? Let's do this now. I'm gonna paste the URL here. It'll take you. This is the branch, the preview deployment. Try going there and just like do example at test.com 123 123, you know, something like that. Try to hit like try to hit it a few times, and let's see if different, you know, locations in this world from different computers, from different IP addresses, the cache is being treated differently. Let's see if that's the case. So yeah, whoever wants, click the link I just sent in the chat and try to log in with some, you know, 123 123. Oh, there's like a team access? Damn. Why though? Isn't this like a public? Let me see. Mm. All deployments and then protect only preview. Yeah, I'm just gonna disable it for now. And then I'm gonna re-enable it later. But can you access it now? Okay, I see. Nice. See some new logs there. There we go. Let's try to filter based on the requests. Function name. Request path is /sign-in. Yeah, let's do request path /sign-in. Only one creating cache whatsoever. Yeah, and there we go. 12, 14, and then now it's 12, 19, 12, 12. Yeah, these are your 3 times. And they actually were cached. See? Okay, this is interesting. This is a good experiment. So we can probably get away with something like the service locator pattern. Have a cache. The only thing that I'm not so sure about is just bring this back up. The only thing that I'm not so sure about is, for example, what happens. Let's see. What happens to the repository and stuff? You know, like we hold the reference to the cache to the service, but not to the repository. Samyaz, isn't this just the RPC? I mean, server actions are remote called procedures, or remote procedure calls, RPC, right? The RPC is a library that does remote procedure calls. Server actions is like a different implementation of it. And it's like a technology is not new. I mean, there was like back in the day when I was doing .NET, there was like Signal R. Again, this is asynchronous notifications, but it's a remote procedure call. But yeah, server actions are in a way RPCs. right? It's just like a different implementation. Yeah, remote procedure call. It is an HTTP call. You can hit server action with with a manually constructed fetch. It's not impossible, but it's not good. You know, they are HTTP calls, anyways. But yeah, what happens if you trigger a deployment? That's a good point. Let's see. Let's. I'm just gonna place this note here just so we can, you know, trigger a push. Trigger another deployment. Let's trigger another deployment and let's see if the cache is still there. I believe it's not gonna be, like, this is a, it's gonna have like a different URL as well. I'm more interested, because check this out. This is the hash of the commit, and I just did another commit. So let's see if, pretty much so far it does work as expected. So far it does work as expected. Oh, look at that. Actually, this domain is the same, right? B9B80C, ED13. If we go back to the previous one, ED13, B90. Yeah, that one is still the same because it's like on a branch. But we'll see. We'll see. So far, yeah. So far, the service locator does work as expected. We're gonna test it again. Let me go back. There we go. We're gonna use the other. We're gonna use this link now. Let me just go deployment protection. I want to disable the protection, and let's try. Let's try this link now. So here's our latest. Let's go to logs. What was that? Request path / sign in. It is a different thing, yeah. Wait, which one is? Let me see again. Settings, deployment protection. It's disabled. Oh, okay. I got it. I pasted the wrong URL. This is the deployment, and this is what I need to send you. There it is. Yeah, this is the other one. Samyaza asks, what SaaS do you recommend for error tracking? Well, I recommend Sentry because I work at Sentry. So you should definitely check out Sentry. It's not just for error though. It's not just for errors. We're working on really cool performance products as well. You get like tracing, distributed tracing, web vitals, database query monitoring. It's like really cool. All right, let me also try this in a separate tab. Go to sign in. Hello, whatnot. Some dummy passwords. Testing only, success. Sign in. There's once, twice, again. There we go. Okay, so let's see now. Request path / sign in. Come on now, sign in. There we go. You. Yeah, it's still the same. The first one is not cached. So we are recreating it. And then from that point on, it is cached. Yeah, this looks like, there we go again. It's all cached. It looks like that the service locator pattern does work. We do keep the cache. And if we were to run this in a, like a node environment, like in a Docker on a long-running server, it's just gonna work. You know, there is no, it's not serverless. It's for server full. So it's simply going to work. Okay, yeah, I like this. I like this. This was a good experiment. A very successful experiment. So the service locator pattern does work. Does this look like a good DX? Technically, we can do these things. Oh, we can do these things outside, right? This get service does not need to be one single function that does everything, right? And it shouldn't be. Maybe even services themselves could be responsible for creating, creating their, but no, it should not be there. It should be above the service layer. Yeah. Because inside of the service, this one, we have the repository. Yeah, or maybe it's not a bad idea. I don't know. Like, maybe each service has a responsibility to, instantiate itself, or like keep it here. Doesn't matter. Doesn't matter. This can be these 3 lines or 2 lines, repository creation and service creation. They can be somewhere. That can be, I don't know, utility function or something like that. Could you on the service locator file? Oh yeah. Here's what I'm gonna do. I'm just gonna put this in a gist and share it so you don't have to like gist.github.com. Yeah, of course. Okay, let's create a public gist and there we go. Yeah, that's all. Yeah, so I'm still thinking about this. If it's simple, like this will work, the get service will grow. That's why, probably that's why there was like a, in the original documentation, or like by the book, the service locator does implement a cache class. As you can see, it's like private static, of course. It does the get service and add service. We have like a more, we have a more merged or like more homogeneous approach, because the service locator does keep its own cache locally, and the get service method also utilizes the cache. It checks the cache. If not, it recreates the services, which is the initial context, the work of the initial context, and then it returns the service. So in a way, this is cache, this is context, and we kind of merged everything into one class. Hey Valinov, how's it going? Yeah, we kind of merged everything into one class. But I guess, we can of course clean it up. It works, I'm actually happy that it works. If we want to go the extra mile, I'm not sure what are like the implications of you know, adding initial context, adding the cache, I believe it's going to be all the same. Yeah, I believe it's going to be all the same. Or maybe. Like if these are in different files and different stuff, we create the content, the initial context here in the cache. Where is it? Oh yeah, it's in the service locator. We always recreate the initial context. That's what I'm seeing from here. Almost 3 hours, and I feel like it was 30 minutes. Honestly, I do feel like it was 30 minutes as well. Yeah. Time flies by when you're having fun. Yeah, so initial context. I mean, of course, it does clean up the code, that's for sure. We already converted this from Java into TypeScript. It's a static block anyways. It works exactly the same. And then the cache implements, you know, get service and add service. And I know it does make sense, you know, to build it this way, just so that the, you know, the cache class has a sole responsibility to get, to be, you know, to give you the service and to add the service. But the logic behind when to add, when to get, it's not the cache class responsibility, right? This is the only responsibility. And the initial context class, again, it has a single responsibility to create an instance of the specific service that we send it to. And the initial context knows how to create the services. And if there is a repository that the service is dependent on, it knows how to create that as well. So that is the thing. If this, like, can this scale? What if we have 10 more services and 10 more repositories, and let's say that the collections repository is also needed in the links service? Because check it out, we didn't continue doing this. When we go to the app/links, we have a different actions file that does a lot of links stuff. You see, await superbase from link. That means in this action, we're, you know, accessing the link table. That means we need a link repository, you know. So we're gonna have, and because of course this is a server action with database calls inside, we need to refactor this to be a link service that's going to use the link repository and do these things. But it's not just that. For example, in this case, let's imagine that this is the links service, right? And this is the create link method of the links service. We use the link repository here. Cool. But check it out. We also use the collections repository. You know, we want to get something from the collections table as well. Therefore, we need to use the collections repository. So links service will be dependent on both the collections repository and the links repository. So my question is, when we go to the service locator, and first we're going to create the collection service, right? We're going to create the collections repository. We're going to pass it to the collection service, and that's it. But then we want to create the location, the links service. That one uses the collections repository, but we have created the collections repository as well, right? If in this case, we can just reuse it because everything is in one class. We have a cache. We can have two caches. We can have a service cache. We can have a repository cache. So when we create the collections repository, we'll add it to the repository cache, and then we create the collection service, we'll add it to the service cache, and then the next time when we want to create the links service, we'll say does the repository cache contain the collection repository? Yeah, do not recreate it. We have already created it once. And that way, both the locations service and the collections service will use the collections repository, but the same one. They will have the same reference to the same repository. I guess that will be the case. So I'm going to rename this to service cache, and we'll create another one called repository cache. Okay. There we go. Get service, try to get the service, cool. If not, and this is the case here, first we need to try to get the repository first. And see, this is why cache is a separate class. Totally understandable. We didn't test the case where the service it's used in different server actions. Maybe the serverless cache is only functions scoped. Oh, that is a really good point. That is a really good point. Let's actually test that out. We have like 20 more minutes, but let's test it out. We did the authentication service, right? Yeah. Here's what we're gonna do. We're gonna go to the create collection is, yeah, let's implement that. Collections actions. Create collection is an authenticated procedure. We don't care about that. We actually don't use this. Okay, interesting. We should use this here. Create collection. We haven't even tested it, but yeah. Create collection. In the repository now. Collections repository. Yeah, create collection. There we go. Collection. Do the fingerprint. Pass the whole data. Throw an error. And we need to create a custom error here so that we can, you know, export the data from the Postgres error outside. And then we just return the DTO. So in this case, we're going to be doing this. Not Supabase. Collections service. On the left side is the action. Service locator. Get service. Collections service. Bring that in, .name. So we have the collection service here. And we want to do this now. Let's just do res equals await collections service dot create collection. Wait, what? Of course, it's any. You see that? It's any. So this needs some typing. Instead of a string, we can use like a class, and then the return type is going to be casted as of that class or that type. Yeah, let's try this. Let's get T inside. Service is of type T. The name is gonna be T dot name, but T needs to extend a class. Is that the, let's see, TypeScript generic extends. Generic extends. There's a type, but we need to make sure that the type that we're sending is actually a class. It cannot be a string. It must be like a class. So we don't actually extends. But can we do like extends class? No. TypeScript generic extends class. If we had an interface, it would like an I don't know iService interface, and it has like a property, then sure. But I don't want to do that. I want to like just extend class. Like it must be a class. Generic type must be class. Generic classes. But I need the type constraint. Yeah, I need to constraint the type, not based on a specific class, but just to be a class. That's all. Maybe let's see. TypeScript generic type constraint type of extends base API. Can we do? Okay. I don't want to have like a base class. That's all I'm saying. It must be a class. Yeah, it must be extends in this case, but then here extends new. No. Because if I extend the class, like class, we're gonna have the name inside, and we can do the thing. And then and this is all TypeScript. I mean, it works. We need the types. Yeah. Yeah, there's no common class that's, describes all of the services. It's an object, yeah. So that's why I think extends name string should work. But we'll see. We'll put a breakpoint here, and we'll see what the service is. So here's a little refactor. Instead of passing a name, we're gonna pass an actual, an actual class, and we're gonna return t, but because this is any. This is the thing. It's any, and I want to do like st, but it's not gonna work. Might be a mistake, yeah. Okay, I guess if we were to do this, I guess we have to have like a common class or interface that will, we can take in and then expand it, export it as unknown. It's gonna work, but like, isn't this like a bad? This is a hack basically. Nevertheless, let's go back into the. So this is gonna work now, collection service, and it's still any. And I probably need. Wait, service locator. Instead of any, I also need to do t here. Oh, come on. Like this. Yeah, because we might not return, right? Based on this, we might not return. Oh yeah, it's an instance of T. Good point. But for the types sake, it still needs to be T. And let's go back now and see collection service. Yes, it is a type of collection service or undefined. So here, if we do no arguments apply, yeah. It's gonna be a type of, yeah. Okay, so this is weird. We can do this. TypeScript. This is TypeScript. Would have been cool, but yeah, you know. Let's do this. We can do name is string. Hey Sebastian, what are we trying to do? We're actually trying to let me just do this. We're actually trying to define the get service as a generic so that it takes in a type and it returns, because in here we have like an any, right? So if we say get service, we lose all of the typings, right? We return the service, but we don't have types for the service. So I was thinking, should we do something like this, where the T extends, and then we had to like do an object here because, you know, I guess an interface would, like an empty interface would work better in this case. But then when we return that, yeah, we do have some set of known services, yeah. Like for here, instead of any, you're thinking we should have like either an authentication service or, yeah, I guess we can do like type services equals, we can type of authentication service or type of collections service for now, and then instead of any we say services, something like this, right? And then do not do this actually extends now, since we have the type one of the services, right? And these are all gonna have a name because they probably should have a name. And then this thing is an authentication service. And then authentication service is not assignable to type services. So not a type of then, right? But an actual service. So here there is no common, there's no interface, therefore there is no name in this case, but this works. So we have T. Yeah. Service dot. Yeah, there's nothing common between them, so I have to do like nasty thing like s and then dot name, hoping that the name, you know, is always going to be there because they're like classes. But we'll see. We'll see about that. Or maybe we should do type of value of stream. Yeah, it's not gonna happen. Okay, let's just run this and see what we get here in the name. If this works, let's also make sure that we have types in here. Yeah, it has to be a type. It has to be a type because we can't pass an instance of the service here. The get service returns the instance. So this has to be a type. And it's going to return type of. It needs to return an instance of that type, but damn it. Yeah. What about this? Let's see. I'm expecting you're gonna type some stuff. Have a type that takes string and returns a service type, and then if it actually is not known, it returns never or something like that. Okay. So like it's always gonna, like, the record is always gonna be a string, but the type is gonna be based on that string, where the key of the record is gonna, yeah. So I believe we need like two types. This type should be a different one, and this type should be a different one. So I'm gonna bring back the services, but they're not gonna be types of. They're not gonna be the types of the services. They are gonna be the services, right? So this works here, but the input is not gonna be it's not gonna be the services. It's gonna be the types. Right? And if we go back to the action now, hold on. So we do need to like explicitly define the return type here. Damn. This is complicated. Still not good. So we have the services and their service types. We're gonna keep the services. We wanna take in a type of them, but we want to return an actual instance of them. Woo! Complicated, but yeah, it is complicated. I thought the laziest way is to, like, force casts, but that's not good. We actually need to, we need to match the types. We have to match the types. And we're running out of time. So maybe this is something that we should think about. Maybe we should think about this a bit better. How do we? And this is all like TypeScript gymnastics. Yeah, this is all TypeScript gymnastics. Hey Harsh, which theme am I using? This is NeoVim. So the theme is raw cyber dream. This one. It's really cool. Yeah, let's try to figure this out for the next stream. Yeah, it does. It does look sick. Let's figure this out for the next stream. What we wanted to do, and we got caught up into this whole thing, was we wanted to test if for example we use the service locator with the cache and everything, if we use that in a different action, in a different function, you know. But you know what? Let's try this. Let's try it just for the sake of, you know. Just for the sake of trying it. I'm gonna undo this. I'm gonna undo this so we're set here, right? This should be, yeah, this should work now. Let's try the, let's try to sign in. This is a sign in with passwords. I'm just gonna copy paste this as a different server action with a different name, just so we have two distinct, seemingly distinct actions, but they're gonna be the same. Okay, so this I'm gonna bring this back. Just so we have sign in, work, etc. I'll bring back the any's just so we don't have the issue. And I'm just gonna like duplicate sign in with pass, and that's it, you know. And then I'm gonna go, we have a sign in here. Hold on. This is sign in with pass, and this is sign in with password. So that's what we want to do, right? Different server actions to see if the cache is shared between different actions, not just like invocations of the actions. That was another test that we wanted to do. So in this case, I can just like copy sign in pass. And where is it? Okay, that was weird. Copy this, sign in pass. Could not do some stuff like that. Okay. Cool. I'm just gonna delete this whole thing. Sign in, pass. No, man, I'm getting tired. Sign in, pass. It's a folder. Copy this one. Sign in, pass into the page. It displays in a weird way, but there it is. There's a page and also the form. sign in pass, paste it there. Ignore the dots. The dots will not look, you know, it won't be the case. And in this, I want to use sign in with pass, not passwords, because that is the different. That's a different the different action. So I want to deploy this now. Let me npm run build. We're gonna deploy this. I'm gonna send you the link in the chat so that we can try both /sign in and /sign in with pass. And we're gonna see, okay, it builds. And we're gonna see testing. Yeah, we got no time to write commit messages right now, but yeah, let's see. Let's go to Vercel. You're kidding me now? There we go. What is going on? Come on now. What is the case? What is the error? Oh yeah. There's an error on the server in a server component, apparently. Yeah, server components, man. So Vercel is having some issues right now. I believe we cannot test this. Let's go back to PHP. Yeah. All right. Let's call it a day. I'm gonna do this. Test cross action cache in Vercel. We're gonna start with this in the next stream, which is gonna be on Monday, same time. We're gonna start with this in the next stream to test if, you know, we have the cache persistent between all the different server actions, or if it's contained only within one server action. And I believe that's going to be the case. For every server action, we saw that users do not matter, right? We attacked one server action and it reused the cache. But if you have multiple server actions, let's see if the cache is going to scale horizontally, whatever it is. Let's see if the cache is still persistent in between actions. If it is, even better. If not, I guess it makes sense for it to, you know, to be treated as a separate one. It does make sense. Actions do separate actions do separate things. So it does make sense for Vercel not to share the cache between different actions, but it does make sense for Vercel to share the cache between different instances of the same action. We're gonna test that next time. Yeah, we're gonna test this on Monday. We're gonna start off with that just so we know, you know, that cache, how the cache behaves, just so we are aware. That is the most important thing. Even if the cache is not persisted, we don't care. You know, it's still a bonus that we have the cache between the instances. But even if we don't have the cache like across the actions, the way that we are creating the services are, you know, cached and not cached, but it's lazy, right? We don't create all of the services before every action. We just create the ones that we need for that action, and that's still okay. You know, that is still okay. Every, you know, Vercel caching thing is all a bonus. So this was a very productive 3-hour stream. The next one, as I mentioned, is going to be on Monday at the same time, 10 a.m. Eastern time. We're going to test the cross-action cache. Regardless of the outcome, this is just for us to be aware. Regardless of the outcome, we will continue figuring out how our service locator pattern, our service locator cache, how to make it type safe. So when we request the authentication service, we also get something that has the type of the authentication service, right? We want to do type matching, and we're going to request a string, but we're going to get back an actual service. So we'll figure that out for the next stream. If we figure that out, then we can say that the service locator pattern works nicely, works, it works good. And it's going to be even better for long-running services. But for serverless, it's still going to be optimized enough, right? Because it's going to lazily create the services and keep them in the cache as long as the platform allows it to cache it. But this was a success. We can see that we don't need a dependency injection. We don't need, fancy stuff like that. I guess we can just continue with the service locator pattern and just, see where we go from there. But if I believe this is the missing piece. If we figure out the service locator, we can use the services anywhere in our app, and they won't be bound just to the server actions. And this architecture with the service locator would mean that it can be used in any backend, right? Like, as long as it's like JavaScript. If it's, for example, Next.js with pages, it's still gonna work because it's just JavaScript, right? We are figuring out the JavaScript part, but where the JavaScript interacts with Next.js APIs, that's like ZSA actions, and that's actually where the service locator class comes into play. So yeah, thank you all for watching. We made 434 views. That is insane. That is crazy. Never seen numbers like that. Thank you to all of the subscribers. This has been a really good stream. So wishing you all a good weekend, and I'm gonna see you on Monday at the same time. Thanks, Cody. You're still watching? Damn, man. thanks for being here. Yeah, let's figure out the service locator next. Take care.